Hi, we are the 6th Degree of Freedom Load Frame Group. I'm Austin.
I'm Aziz, and I'm Travis.
Alright, so the responsibilities of our team are to design a load frame around this hexapod in order to test coupons of varying length between 8 and 12 inches under complex loadings. This means that the frame that we will be designing must be able to withstand the full load of this hexapod in any direction or rotation with minimal deformation. In order to acquire minimal deformation, we will be designing our load frame with maximum stiffness in mind and cost as a secondary concern. In addition, our frame must interface with the universal grip adapter that will be shown later in order to interface with the grips and load cell that are attached to the coupons. Also, the load frame and hexapod are not expected to be portable, and by the end of this project, the hexapod must be operated in some controlled manner.
So this is the hexapod that was acquired by the MSU Composites Research Technology Group here on campus from Western Transportation Institute, and they plan on using this as a material testing device. The 6 servo actuators down here is what actually powers it. It makes it to where it can move and rotate in 6 degrees of freedom and apply a tensile load of up to 10,000 pounds. This here is the computer that powers and controls the hexapod. Originally, this computer was mounted here in the middle of the hexapod. However, to make room for our design, we are moving it to the outside of the hexapod due to the fact the actuators have a long enough cable and utilize the internal parts of the hexapod. This here is the grip adapter. It's got 2 threaded ends. One threaded end goes into the load frame. The other threaded end goes onto a grip. In this space right here, they typically have a washer that preloads it. Make sure that the threads do not fail.
So pictured on this image is the load cell and grip attachments that we will be using in our design. We use the sizing of the combination of these two to figure out the distances between the top and bottom of our load frame. These two will be connected to our load frame by the threaded rod on the grip adapter that was shown before.
Here is an overview of our final design, and this assembly here is our hexapod, and this is the top frame that's going to be attached on the top plate of the hexapod, and this is the bottom frame which is going to be attached on the bottom plate of the hexapod. And here is the adapter where the load cell and the grip are going to attach to, and the coupon is going to pass through that plate here.
Alright, so here is the top assembly that will rest on the top hexapod plate there. The top assembly consists of 3 of these vertical beams. These vertical beams have these small plates that will be welded to them at the top and will be connected using SAE grade 5 3/4 inch bolts. In addition, we have these horizontal beams right here. We have 3 of those that will be welded together in this middle section following these lines. In addition, we have this top plate and this bottom plate pictured here that will be connected to the beams using the SAE grade 5 bolts that I said earlier. We also have these L brackets with gussets shown here that will reinforce the connections between the horizontal and vertical beams.
This here is the bottom assembly. Right here in the middle is where we put our bottom plate. That's why we had to move the computer out earlier so we could run the coupon through the middle of it. The bottom grip plate here in the middle is bolted to the bottom plate, which is bolted to the hexapod frame.
Shown here is the finite element analysis of the bottom assembly. Because we are unsure of the load capability of the hexapod, we analyzed the assembly with twice as much as estimated 10,000 pound tensile load. We used a 20,000 load tensile and 12,000 foot-pound torque. And the maximum deformation shown is approximately 19 thousandths of an inch. And shown here is the top assembly, and as it's shown, it has a maximum deformation of 6 thousandths of an inch.
For future considerations, the grip adapter, which was a part given us to design around, fails under the torsional loading. small diameter of the adapter causes the top grip plate shown here to fail as well, as the stress exceeds the yield of the A36 steel we are planning on using. In conclusion, we will find a solution to this problem in the near future.